In this video we will talk about list slices. And slice is a part of list. So if we want to take like a sub part or sub list of a certain list, then we can use slicing. And to use slice or to take a slice, then we need to specify the starting point and the ending point. Basically it's a starting index and the ending index. And the start index is included and the end index is excluded. So let's have an example here. So we will have elements 1, 2, 3, 4 and 5. And let's draw here the indices also 1, 2, 3, 4. As was pointed out, the first element has an index 0. And to take a slice, then we need to specify the starting point and the end point. So, and if we specify, for example, the first example here is 1 and 3. But what happens is that the first index is included and the second one or the end index is excluded. So here is the, let's say it's n. And if we say that we want to take slice from 1 to 3, then what happens is we will start here, but we don't take the end index into account. So basically in this example we will have the elements with indices 1 and 2. And the same applies, for example, if we take 0 to 4. 0 is the first one, so we start here, and the 4 itself is not included, so we will get first four elements. Then, for example, if we take 2 from 2, what happens is that the element at position 2 is included, but as the end index 2 is excluded, then we basically get nothing. So it's basically something like here. So we'll just have an empty list here. And in case we will just take 2 to 3, then what happens is that we get this element here. So it's basically a list of one element. But you have to see that in this case we will get list of 3, but in this case if we use just one element, then it's 3. So that's the difference. Basically they point to the same place or same part of the list, but in this case we only get one element. With slicing we always get a list. So, and the default starting index is 0 and the default ending index is the length of the list. So, and what can be done is that the default values can be omitted. So for example, the same here can be written as this. So we just leave out the starting index and then it's considered as 0. The same applies, for example, if we want to take everything starting from, let's say, 3 up to the end of the list. So basically here we get this sublist. What can also be done, for example, we can do this. So here basically the start and the end both are omitted. What happens is that we get the same list. But slice always creates a copy, so basically it's a copy of a list. We'll talk about this in the next slide. What also can be done is we can use negative indices. So for example, let's write the indexes here, and we can use them as we used to point to the specific positions. We can take, for example, 2 last elements by writing -2 and omit the end index. It's more convenient to do this than to use length of the list -2. Also the end index could be negative. So for example, we could do -4 up to -2. And then it's basically it works the same way. So we start here and we end here. So basically it's the same as 2 and 4. There was something probably somewhere here. no, the -4 and -2 is same as 1 and 3, so it's the same as this one here. Along with the start and end indices, we can use a third value inside the slice to specify the step. By default, the step is 1. So 1 basically means that we take every element in a row or consecutive elements, but we can do it differently. So we can specify concrete step, and then we can take, for example, every second or every third element. Here are some examples. So the first one is so that we will take 0, 3, and 2. What happens is that we start from 0, so basically it's included. We end in 3, so basically it's up it's basically this one here. So I try to fit in those, squeeze in those lines here. So, and we take every second element. So we start from this one, then we take this one. Okay, as the slice itself is over, we don't get any other elements, but basically, yeah, we get every second element. We can always omit the start and end and write 3, for example, then every third element is taken. 1, 4, and so on. The step can be negative. For example, if we write -1 here, then what happens is we take every element but in backwards direction. So basically we start from 5, 4, 3, 2, 1. So basically if you want to reverse the list, then it's quite a nice way to do that. If we use negative steps, then we have to start from the right side, and the end index should be on the left side of the start position. So for example, to take every second element, we can write so that we start from 5 up to 1, for example, and let's say -2 here, -2. What happens is that we start our slice from here. We take it up to 1, but 1 is not included. So yeah, I probably should write 4 here because my list is 4 elements, has 4 elements. So basically it's 4, 1, and -2. And we start from the index 4. We go up to index 1, but 1 is not included. So basically we end up in the at position 2, and we take every other element. So it's basically 5 and 3. So you have to take into consideration that if you are using negative steps, then also the start and end positions have to be reversed. So you have to start from the higher position and end in a lower position. Otherwise, you don't get anything. And with slice, it's convenient to have, for example, in the given example, I can write something like 7 up to 10. As you can see, we don't have elements besides 4. 4 is the last index in the list. In this case, we'll just get an empty list. And if you compare, for example, in the given list, if you take element at position 5, we would get an error. But with slicing, we would just get an empty list. At certain problems or at certain points, it's very convenient to use this way. So if you don't want to check whether we have those positions, or are those both inside the list, or one is inside list and the other is not, then with slicing you don't have to do that. You would just end up with an empty list. But if you just want to take one element, you have to always check whether the 5 is inside the list, or otherwise you will just get an error. So it's nice to know that you can take elements using slices outside the list, you don't get an error, but you just get an empty list in that case. It's also nice to know that with slicing you always get a copy of a list. So, and the nicest way to copy the whole list is to just make a slice of it. There are other ways to do it. You can create a new list and take every element and put it to another list and so on. There are also different other ways, but that's the shortest way to write a copy of a list. And now what happens is if I change one list, for example, the n list, let's write it as m is n, copy of n, then in this case, if we change the n list, it doesn't modify the m, and so vice versa. So they are basically creating a copy in the memory. You will have this list, and another list will be created, which basically is the same. 5, and now the m points to this list. And if I change this one, this doesn't affect the n list, and vice versa. If I would just write m, n is assigned to m, then those both would point to the same list. And if I change something in n, it also changes for m. So whatever you do, if you take slice, for example, some smaller part of the list, and you get the list as a result, and if you change this list or if you change this list, those are not related anyway, so they are basically different lists. There, of course, can be cases where the elements themselves are objects, mutable objects, but that will be a different story, and we'll cover this in later examples. So here is an example. If I have a numbers list, I will make a slice, which is basically a slice of everything, or we can say it's a copy of numbers. And if I change the slice, the first element of a slice variable or the slice list, you can see that the numbers variable or the list behind this variable is still the same, but the slice variable points to a different list where the first element is 100. As I pointed out, that the slicing or taking a slice from a list makes a copy. But in Python, you have a way to modify sub part of a list. So what you can do is you can use slice to modify some certain part of the list. And here is, for example, the case where we have a list and I will change one part of the list. For example, I would say that let's change those 2 and 3 into something else. I could write so that n 1, 3 equals, and I will put new values here, 4 and 7, for example. Now what happens is that the elements which correspond to those or correspond to this slice are those 2, and I will put this list in replace to this this slice part. In this example, the slice has 2 elements, and the new list which I try to put in have the same length, but they don't have to be. So here is an example where I take the same part but write only, let's say, 0 there. Now what happens is that instead of those 2 elements, I will have only 0 there, and I will end up with a list 4 and 5. So the 0 is put into here, and the 2 and 3 which were here, they are just replaced with shorter list. The same can be done so that instead of 2 elements, I will have 4 elements, and so on. This is something which a lot of programming languages don't offer, so it's also nice and convenient way to modify a list. Although it's usually not done because there are not so many ways or so many problems where you actually have to do something like that. Or then you can always use some other like methods where you just, for example, replace this and this value separately.